Efficiency, capacity, utilization, and production volume ratios. We need to calculate here ratios, okay? Ratios. And we will remember, we will learn some formulas here. These are very interesting actually. So there are three ratios: efficiency ratio, capacity ratio, and production volume ratio. Okay, number one. So there are three ratios. And you should remember that this production volume ratio, when you will calculate, you will see it is actually equal to efficiency ratio multiplied by capacity ratio. Okay, so whatever we will calculate for efficiency ratio and we will calculate capacity ratio, if you multiply both of them, you get production volume ratio. Now, what these ratios are going to tell us? The name efficiency, it says quite a lot. Efficiency means that how fast are you doing things, okay? So for example, if you see that I told you that 40 pages example, which I was giving you in the previous lecture, that, okay, I'll speak it again. You type 5 pages per hour, okay? This is your speed. So you work for us and your speed is 5 pages per hour. This is what we agreed with you. Then what happened that we gave you 40 pages to type, and so logically 40 pages divided by 5 should take 8 hours. So when I gave you this work, I thought that you will return me back this work within 8 hours. But then what happened that actually your actual time taken was 9 hours. So I might not be very happy with you, because I said that, see, you said that you can do 5 pages per hour. I gave you 40 pages, so you should return me back the work in 8 hours. But you are coming back in 9 hours. So your efficiency is actually less. You know what? If you exactly do it, let's suppose you exactly do it in 40 hours. Let's suppose you exactly do it in 40 hours. I'm sorry, 8 hours. You exactly do it in 8 hours. So you were expected to do it in 8 hours and you do it in hours. So your efficiency ratio should be 100%. It should be 100% because you should have taken 8 hours and you actually took 8 hours. So nothing more, nothing less, nothing saved, nothing wasted. Your efficiency is 100% in this situation. However, what we see that you took actually 9 hours. So when you take more time, it means that you are working probably slow. So if you are slow, your efficiency ratio should be less than, it should be, less than 100%. Maybe it is 90% only. So I said, oh, you know what? You are not working 100%. You are not giving me 100%. You are only giving 90%. Your productivity is 90%. Your efficiency is 90%. So efficiency will talk about the speed with which we deliver the work. Okay, this is one thing. Capacity ratio, by the way, do not get worried. I'm going to show you the formulas, but before I actually show you the formula, I just want to, give you some understanding so that you don't have to learn the formula by heart. Instead, you should be able to understand it. Capacity is actually about, how much more or how much less you work. So it is about more hours or less hours. So let's suppose that you are every day you come in the morning, you come to office in the morning at 9 and you sit until 6, and in between there is 1 hour lunch break, whatever. So you work 8 hours. This is what happens, 8 hours. So last night I saw that you were sitting in office until 8 p.m. Until 8 p.m. And you say, you know what, I was working 2 hours extra. I did not work 8 hours. In fact, I worked for 10 hours. So that is called capacity. So you are working more. That probably is a good sign. But then, so what happened that on this day, you worked for 10 hours. So you are actually working more than the capacity. Capacity was 8 hours. You actually worked for 10 hours. Now, how much work did you actually produce in 10 hours? That is a different case. Because, for example, You come back and say, oh, you know what? I was working until 8 p.m. and I worked 2 hours more. And then I say, how many pages did you type? You said 40. Oh, you said 40 pages I typed. Remember, you had 5 pages per hour. So if you are working for 10 hours, you should be doing probably 50 pages, but you did only 40 pages. So what I would say here that see, as for capacity, you are doing good. So your capacity ratio will be more than 100%. It will be more than 100% because instead of giving 8 hours, you gave 10 hours. But your efficiency ratio is less, and that should be less than 100% because your speed was not enough. Okay, you were working slow, although you were working for a lot of time, but you were not working as fast as we expect you to work. So in this situation, if you give me 40 pages and you sit 8 hours, 10 hours. So when I see that you work, because based on 10 hours, I was expecting 50 pages from you. So you gave 40, your efficiency goes down. But then you say for 8, instead of 8, I say 10 hours, so your capacity is more. And when you will multiply, so let's suppose some numbers, okay? Let's suppose some numbers. So efficiency is less than 100, so probably efficiency is 90%. And capacity is more than 100%. Let's suppose that it is 110%. And because I told you that the production volume ratio is a multiplication of efficiency and capacity, I told you that production volume ratio is actually equal to efficiency ratio multiplied by capacity ratio. So it means that, 0.9, 90% is called 0.9. 90% means 0.9 multiplied by capacity, which is, 1.10. 100% mean 110% means 1.10. If you are confused with zeros, let me just remove zeros and I can say efficiency is 90% multiplied by capacity is 110%. And then when you multiply 10, let me get my calculator. When you get 110 times 90, it gives me 99%. So you are actually, what you did to me, your production volume, your production and the production volume is 99%. So your, production volume ratio should have been calculated as 99%. So this is some introduction to this three ratios. Now let's see exactly how do they work. It says standard hours are useful in computing efficiency, capacity utilization. Standard hours I used. Remember, you said I did 40 pages. I divide them with 5, and I said that this work should have been completed in 8 hours. You brought me 9 hours, etc. So we use this standard hour thing to calculate. Okay. Then it says that the efficiency ratio measures the efficiency of the labor force by comparing equivalent standard hours, by comparing equivalent standard hours for work produced and actual hours. So how much were standard hours equivalent? You should have done these 40 pages in 8 hours. And then I compare it with the time you have taken. Actual hours taken are 9. So I compare 8 with 9 and I see that if you are taking more or if you are taking less. So this is how the definition says. The capacity ratio compares actual hours worked, like we said that 10 hours, and the budgeted hours, which were 8 hours. Okay. And then we see if we worked more hours or if we worked less hours. So we compare 10 with 8 in this case. And then we talk about the third one, which is production volume. Production volume compares the number of standard hours equivalent to the actual work produced and budgeted hours. So number of standard hours equivalent to the actual work produced. So we said that you did 40 pages and 40 pages should have taken only 8 hours. Okay. So we compare it with the work produced and the budgeted hours. How many hours were budgeted? 8. How many hours were taken? 9. How much work was done? 40. How much work should have been done? 50. And we compare these numbers. So let's see the formulas now for, okay. Oh my God, my goodness, what these slides they have given to me. I need to understand myself first before I start explaining because my team made these slides. Okay, so you've got budget, You planned 10,000 units and you thought that, okay, forget about this other part. Otherwise, you will get confused. I'll just keep it for some moment. I'll just remove it. Okay. So we see like this. So you thought that, or you planned that, your budget was that you would produce 10,000 units, and the cost of producing 10,000 units should have been $12,000. So it is about, material and cost. It's not about labor in this example. Okay. So your budgeted cost is $12,000 divided by 10,000 units. So it means that the standard cost of producing one unit, if I divide these two numbers, 120,000 by 12,000 by 10,000, your standard cost of producing one unit is $12. Okay. This is what you planned. This is what you budgeted. This is what you thought how it should go. Okay. Then what happens? In reality, what you did actually, let's complete this one. So what you did, instead of producing 10,000 units, you produced 11,000 units. Bravo. You did well. You produced more units. But then your cost was also more, 13,000, 130,000. So while producing 1,000 additional units, you actually spent $10,000 more. Okay. Now I cannot compare these numbers. So my budget was $120,000, but actually I spent $130,000. So can I compare these two numbers? Answer is that we cannot compare these two numbers because $120,000 was supposed to be for 10,000 units. We in reality produced 11,000 units. So therefore, this cost is not for 10,000. So I cannot compare these. It would be very unfair if I say that, oh, you spent 10K extra. If I say that you spent 10K extra, 10,000 extra, you would immediately say, sir, I also produced 1,000 units more. Please consider that as well. That makes sense. So I say, okay, now this budget and this actual, I cannot compare. Why? Because the number of units are different. So I make another column. I make another column here, which I performance measurement column. And then I say that, let me just see if there is something more different here. Let me see if there is nothing hidden. Okay, I thought maybe something is hidden. So I say, okay, considering 11,000 units. So this actual and performance measurement, because actual output is 11,000, here I should also consider 11,000. I said that what was my standard cost? My standard cost was $12. When I divided these two numbers, I got $12. One unit cost should be $12. So if I produce 11,000 and I have multiplied with 12, the answer should be 132,000. See, understand. For 10,000 units, multiplied by 12, your budget was 120,000. But if you say that I'm producing 11,000 units, if you say I produce 11,000 units, so then 11,000 units times 12, your cost should have been 132,000. Okay, this is, we got this 132. We say that if I produce 11,000, so what was the cost of one unit? I produced 11,000. Forget about 10. 10 was gone. 10 was the budget. We never made 10. We made 11. So if we talk about 11 and one unit was 12, my cost should have been $132,000. Yeah, now that makes sense. Now we can compare these two now. These two we can compare. I mean, these two we cannot compare because this 120 was 10,000 units, which is not the case. In reality, we produced 11. So we say that for 11,000 units, we should have, the cost should have been, $132,000, but the cost was $130,000. You did great. You actually saved $2,000. You actually saved $2,000. Okay. So we are happy with you because if we consider that one unit is for 12, the key lies here. because the key lies here. We say that 1 unit is for 12. So for 11,000, it should have been 132. You did the same job in 130. You saved us $2,000. We are happy with you. Now we see one more thing here. This is for, in terms of labor hours. Before I was showing you for material, this is for labor hours. And it does not make much difference. Instead of material, we are just now putting labor, okay? Otherwise, the logic, the concept is same. What is our budget? Budget is that we will spend 75,000 hours and we will produce 25,000 units. So when I divide 75 with 25, 1 unit should take 3 hours. 1 unit should be produced in 3 hours. This is my standard labor. I should have been, or I should be making every or each unit in 3 hours. Okay. Now we want to see how much efficient we are, how good or how bad we are doing. So we say, okay, what happens in reality? Actually, what happened? Actually, this happened that instead of working for 75,000 hours, you worked for 85,000 hours. Remember, I said that you had a day for 8 hours, but on a certain day, you worked until 8 p.m. and you came out and you say, I worked 2 hours more. I worked 10 hours. In this case, we say that we thought that in the month of January, we will work 75,000 hours. But in the month of January, we actually worked 85,000 hours. So when we worked more, it is expected that we also produce more. So if you see that instead of making 25,000 units, you made actually 26,000 units. So I would ask you, you know what? You were supposed to spend 75,000 hours. Why did you work for 85,000? And you say, you know what? Because I produced more. I produced more units. So now, can I compare these two numbers? The answer is no, you cannot compare because this number is for 25,000 units and this number is for 26,000 units. Their bases are different, so I cannot compare these two numbers. I again make another column performance measure. I say, okay, what is the standard time per unit? How much time 1 unit takes usually? And you said 3 hours. So how many units we actually made? We actually made 26,000 units. So let's see, 26,000 times 3, it gives me 78,000 hours. So it means that this 85,000, I'm sorry, this 26,000 output, 26,000 output should have taken 78,000 hours. But in reality, it took only 85,000 hours. Isn't it good? Or is it bad? I think that's a bad news. Because if you are making 26,000 units and every unit should take 3 hours, you should finish the work in 78,000 hours. But you are finishing the work in 85,000 hours. Your efficiency is less than 100%. Your efficiency is less than 100%. So this is what it was. 85,000 hours you worked, which is more. And this is how much it should have been, how much it should have been. So you should have completed the task in 78,000 hours. When you are, so you actually lost 7,000 hours. And you know that for each hour we have to pay money. So if our wage is $5 per hour, which is very minimum, if our wage is $5 per hour, which is very minimum, we are actually losing some $35,000 out of this scenario. This scenario is going to cause us a loss of $35,000 because you spent additional hours, because you spent more hours. Okay. So this is how we compare. Remember that example of typing the page in your mind. That was a simple example. Numbers were simple, numbers were straightforward, and the same logic will apply in many different situations. In fact, all of the future situations which you will see. So we talk about now efficiency ratio. Using the same numbers which we have here, 78, 85, and whatever, we will find out our ratios, okay? So I hope that by now you people already remember these numbers. So formula to learn standard hours over actual hours. So for efficiency ratio, the formula is standard hours divided by actual hours. Standard hours means how much it should have been. Actual hours was how much it was. So how much it should have been was 78,000. Remember 26,000 hour, 26,000 units multiplied by 3. This is how much it should have been. What it should have been is called standard. How much actually you took hours? 85,000. Your efficiency is less, 91%. It's very obvious because you should have taken 78,000 hours and you took 85,000 hours. You worked really slow. So your efficiency, your productivity was 91.76%. Then we calculate the next one, which is capacity ratio. The formula for capacity ratio is actual hours divided by budgeted hours. So how much were actual hours? Actual hours worked are 85,000. And how much were budgeted hours? Budgeted hours, if I go back, this because you might not remember. So if I go back to the first screen, this was budgeted hours. We thought 75. This was budgeted hours, okay? So you will take budget hours from the budget. So if you come back here, so budget hours, it says actual hours divided by budget hours, which means 85,000 were my actual hours, which we did. How much we budgeted was 75. So you actually worked more than the capacity, 133%. Efficiency ratio was down to 91%, 91.67% something. And capacity ratio is up to 133% because you worked more hours. Instead of working 75, you worked 85,000. So that makes some logic. Next is my production volume ratio. And as I told you that production volume, you have two methods. Either you multiply these two, like this number, which is 91.76 multiplied by 133.33. You multiply these two, you get production volume straight. But there is a direct formula as well. There is a direct formula for production volume as well. And you can remember that formula. And that's, it says standard hours. How many were standard hours? I think 26,000 units we produced. 26, 78 was there, right? So 26 divided by 3, multiplied by 3. So 78,000 was my standard hours. The work which I produced, 26,000 units, should have taken 78,000 hours. And how much was my budgeted hours? In my actual budget, I put 75,000 hours. So you divide these two numbers and you multiply it with 100 and you get the answer, 104%. Okay. You want to check it? Let's check it. The first one, efficiency was 91.76%. The second one was capacity was 133.33%. And if I multiply these two, let me do it on my calculator. You can also check it by yourself so that you are confident. 91.76 multiplied by 133.33. It gives you 91.76 multiplied by 133.33 divided by 100. Wait a minute. 0.9176 times 1.3333, 1.22. There is some mistake in some number here because to me it get 122%. Let me see, 78,000 divided by 75,000. This is correct. 104 is correct. Let's move on. 85,000 divided by 75,000 into 100. This is actually wrong calculation. It is not 133. It should be 113.33. Okay. So that's why the answer was not coming. It is when you will calculate 85 by 75, it should not be 133. Instead, it should be 113.33. So that's a typing mistake. Let me check the other one also, because the answer should always come same. Okay. So 78,000 divided by 85,000 into 100. 91.76. This is correct. This is correct. So if I come back here again and I want to verify, I mean, either I use the formula or I can multiply the previous ones. 91.76% multiplied by 113. I'm not taking 133, 113.33%. When you multiply these two numbers, you should get the same answer. Okay. So I'll do it 91.76 multiplied by 113.33, and then I divide it with 100, and I get 103.99, which means 104%. Okay. This is what I get answer. So you can actually do production volume by using the formula, or you can find out production volume by multiply efficiency ratio with the capacity ratio. You get the same answer. Okay. So these are the three ratios we just learned. And then we have, yeah, that's the same. Oh my God. You see, I'm sorry for that thing. So they have actually put here 113, and it comes out to the same. So in the beginning, they somewhere wrote 133, which was a typing error. I will correct it in my slides. Then we see there are some questions. You will see these questions in your slides, and then we will do have a separate session for doing questions as well. So this topic for three ratios is finished.